Hello everyone, this is Rithun from CKF, and today I'll be going over USACO 2015 December contest bronze problem 2 speeding ticket. Let's first start off by reading the problem. Always a troublemaker, Bessie the cow has stolen Farmer John's tractor and taken off the road. The road is exactly 100 miles, and Bessie drives the entire length of the road before ultimately being pulled over by a police officer, who gives Bessie a ticket for exceeding the speed limit, for having an expired license, and for operating a motor vehicle while being a cow. While Bessie concedes the last two tickets were probably valid, she questions whether the police officer was correct in issuing the speeding ticket, and she wants to determine for herself if she has indeed driven faster than the speeding limit for her part of the journey. The road is divided into n segments, each described by a positive integer length in miles, as well as an integer speed limit in the range 1 to 100 miles per hour. As the road is 100 miles long, the length of all n segments add up to 100. For example, the road might start with a segment of length 45 miles, while speed limit 70, and it might end with a segment length of 55 miles, with a speed limit 60. Bessie's journey can be described by a series of segments, m of them. During each segment, she travels a certain positive integer number of miles at a certain integer speed. For example, she might begin by traveling 50 miles at a speed of 65, and then another 50 miles at a speed of 55, and the length of all m segments add up to 100 miles. Farmer John's tractor could drive 100 miles per hour at its fastest. Given the information above, please determine the maximum amount over the speed limit that Bessie travels during any part of her journey. Now let's look at the input format. The first n line of the input contains n and m, separated by a space. The first number is n and second is m. The next n lines contains two integers describing a road segment, giving its length and speed limit. The next m lines contains two integers describing segment in Bessie's journey, given the length and the speed at which Bessie was driving. So this segment will be n, and these segments will be m. M will be Bessie's, and n will be the current speed limit and road segment. Now, let's see how the sample input was solved. First, both n and m were equal, so both segments will be equal. The road contains three segments, 40 miles at 75 miles per hour, followed by 50 miles at 35 miles per hour, then 10 miles at 45 miles per hour. Bessie drives three segments, 40 miles at 76 miles per hour, 20 miles at 30 miles per hour, and 40 miles at 40 miles per hour. During her first segment, she's slightly over the speed limit. So, in the first 40 miles, you're only supposed to drive 75. In her first 40 miles, she drove 76, meaning she was 1 over the speed limit. And the next 50 miles, you're only allowed to drive under 35. In the next 20 miles, she drove 30. That means in the remaining 30 miles of this 40, she's also supposed to drive 35. But she drove 40 in those 30 mile segments, meaning she went 5 over the speed limit. And the last 10 segment of her journey, she drove under the speed limit. So her answer would be 5. And now, here's some ways to simplify the problem. Instead of adding each number individually, how about we add each mile corresponding to speed limit? So the first mile would be 75, and a mile number 90 would be 35, for example. And this way, we don't have to compare between segments, we can compare by each individual mile. So now let's look at how I did this code. First, I inputted a scanner so I could get the inputs. I made a new scanner, so I named this input, got a phrase to get n and m. The first string will be n and second string will be m. And then since I want to count each individual miles and total miles is 100, I set up a integer of arrays to 100, and I set up index so I could add each individual index. I got the next line, and m and s representing these values, 40 and 75 for example. and at each index I set up to the speed and add index every time. I did the same thing for Bessie, and now for max over. I got the speed difference between Bessie and the current miles that you're supposed to go to, and I set max over to the maximum number of the current one. For example, in the first segment, she went 1 over the speed limit, meaning if the current is 0 and her speed diff is 1, using math.max, I'll get the maximum number, which will be 1, and then max over will be set to 1. And at a certain point, it will be set to 5, because here at line 60, she's supposed to be going 35, but she's been going 40. So that'll be set to 5. And then I'll print out max over to set up the answer. And that's it for today. Please check our backlogs to check other previous codes, and I'll see you in the next video. Thank you.